Hello, right. So this is another model question. Now we are looking at vertical motion here, vertical simple harmonic motion. Right, so here's the thing. A particle is attached to a fixed point on a ceiling. So this particle, let's say of mass m, attached to a fixed point on the ceiling. This point, let's say, is the point. By an elastic string. So they say that this string is elastic and the natural length is L. This is the natural length. So when the particle is at this point, the string is not under tension. Right, then elastic modulus, they say that elastic modulus is mg. Mg is the elastic modulus. Right. So first part, show its simple harmonic for x. So what is x and E? What is E? When you release it, you know that this will not be this will not settle at this point due to gravity. It will be pulling downwards, and the particle will settle at a point right here. That means when the weight of the particle is equal to the tension provided at this point, let's call it T, then the particle will be under equilibrium. So first of all, we should find what E is. How do you find E? Use this formula, T equals lambda x divided by L. Now x is E. Then tension. Now F equal, put F equal ma, because then you get T minus mg equals 0. So T becomes mg now. T is equal to the weight. Lambda is mg over L. Let's call it 2 mg. Yes, let's call it 2 mg. 2 mg. So this is 2 i's. Therefore, E would be L by 2. So what is the extension? When it is released, the extension up to the equilibrium point from the starting point would be L by 2. If the natural length is L, this part would be L by 2. So let me just write it somewhere. L over 2, this part here. Okay. So they say that show this is simple harmonic for x modulus. What is x? To prove that the particle moves on the simple harmonic motion, you're gonna have to sketch a general point, which is a stretch point, unbalanced point. So let's take this is O, level of O. So I have stretched the particle downwards by an amount x. So in this direction you would have acceleration. If this displacement, if the displacement is less than E, the modulus of the displacement is less than E, that means this x could be on either side, should be down, below O or above O. If x is less than E, that means if you take above O, this part, the particle will not go above B level B. It will not go above level B, right? So the maximum amplitude would be always less than this amount, So the particle will be under simple harmonic motion. So if the displacement is greater than E, that means if you are going above the O line, x is greater than E, right? So you can see that when you move, you can move above the line B. If you move above the line B, the string will become slack. So when you move above B, it will not be simple harmonic. It will be vertical motion under gravity. So that's why it asks us to show it is simple harmonic for x is less than E, and partly simple harmonic for x is greater than E. Right, so we have figured out what extension is. Now this is a general point. Put F equal ma. Right. So we take this is F equal ma downwards, mg is below, mg is downward, so mg minus t is upward, minus mx double dot. So mg minus, how do you find t? Lambda is 2mg, so write 2mg. Then what is the extension? Now the natural length is L, so you write L below. Extension would be this part plus x. So L by 2 plus x. L by 2 plus x is equal to mx double dot. So you can get rid of m. So if you take g over L outside, let's take minus g over L, then this part becomes plus x plus L by 2, and here you get a minus L by 2 x double dot. So these two parts cancel out and you get g over L x double dot. Right. So what is this? You can write it as square of root g over L. This is the characteristic equation. So this is simple harmonic. Now for any x, for x, let's say x, when x is between, let's just call it like this, less than e. Okay. If x bar is greater than e, it will be partly simple harmonic up to b. So suppose this is the I didn't write it completely because this part comes next. So suppose this is the amplitude. Here you have extended up to this point, then from this point up to this point and back, the particle behaves simply harmonically. So from this point above, particle is not moving under simple harmonic motion. Right, so we have showed this one now.